Looks like we've got most of the people in. So my name is Tina Reed. I'm a product design engineer at Autodesk. And so what I do is I go out and work with companies or work with makerspaces or partnership with incubator spaces, and I help them design cool things and tell their stories and work on cool projects together. Today I'm going to be showing you just sort of a quick overview of how to get started with Fusion, how to think about designing in Fusion, what to work on. And to do that, we're going to go through the process of making, I hope you can see this, this clamp. Not the most exciting part in the entire world, but it gives us a good idea of how to approach things, how to start thinking about them, and how to design with certain tools in Fusion. So we're going to be going over that. Hopefully it'll be useful information to you. Feel free to, throw out any questions that you have in the question box. You should see it on the right side of your screen where that webinar stuff is. Send me a question. It might take me, 5 or 6 seconds to actually see it before I can answer, but as soon as I look at it, I'll be able to check it for you. We'll also have some time at the end to kind of go over, any questions particularly, but I'm one who likes to go ahead and do it whenever we're in the thick of it, so feel free to do that. To get it started, I just figured I'd let you know a quick overview of Fusion 360. If you haven't used it before, it's Autodesk's newest CAD software, so we use it a lot for consumer product design and machine design, lots of different applications, but it's sort of really special in the sense that it's our vision of the future of how we're going to be designing and making things. And so right now, it's sort of a one-stop shop where you can go from a thought in your head to a product on the shelf or a prototype in your hand, all in one space. So it's got CAM functionality as well as like rendering and animations and parametric modeling and sculpted modeling. And the idea is that you should have one space where mechanical engineers and industrial designers can get together and design something in the same realm. So if you ever want some inspiration or want to know what Fusion can do some more, if you go to the Fusion website, it's fusion360.autodesk.com. In the community section, there's one called Gallery, and here you can either go look at other people's models that they posted, or you can post your own, share things, comment, have a conversation about it. You'll find everything from like really hardcore, like this is a steam engine, like heavy machinery, all the way down to like furniture or trinkets to go on your desk. But it's a great space to really see what Fusion is capable of and what you're capable of through Fusion. So given that, I'm going to go ahead and get started, and I'm going to start off just giving you a quick tour of the interface for Fusion. So when you open it at first, this is what you'll see, an empty screen here, and it'll open up to a blank file. And you hear a lot about Fusion being cloud-enabled. I'm doing little air quotes with my fingers right now. Cloud-enabled, meaning that we take an approach with Fusion that we think is a smart way to use the cloud. So you can use all of Fusion's functionality online or offline. You don't need Wi-Fi or anything for it. But some of the more intensive processes you can sort of export out to the cloud. So for instance, if you're having a really awesome render, you can take that rendering. I'll show you an example. Like let's say you have a lamp here, and I wanted to go to the rendering space and take a look at it. When you're in here, and I'm just going to hit ray tracing, I'll show you a bit more about this soon. But what it does is it renders locally on your computer, and it just keeps going until it's finished, and then you can say save. But you also can't do anything else. You can't update this model while it's rendering. It has to sit and do it, using the resources that are there. But if you click the cloud rendering tool, it gives you the option to go in and use Autodesk outside servers to get a full render like this one. And you do that without having to tie up your local computer. So you can ship off 10 or 15 renders and then go keep working on your model afterwards. We also use the cloud for collaborative purposes, which is sort of a whole other discussion. If you have questions about that, let me know and we can kind of talk about it. But basically all of your files are stored on the cloud. So in Fusion, there's a little 9 square icon over here that's a show data panel, and if you click on it, it opens up all of your files that you have saved on the cloud. And Fusion has to work off a file that has previously been saved to the cloud. However, they all cache locally so that you can access them without having to go to the cloud. You can still work on them. But in here, you've got things called projects. And projects are essentially like folders. So, if you have a particular group that's working on something, you can make a project for it. Once it's open, you can invite people. You can click on the people button and invite others to be a part of it. Everybody can comment on things. They can post for things. They can share those models out. They can work on them. You can give certain, there's certain ways to share them where people can have access and actually edit it versus people can go mark up a 3D image on the computer, in the browser. There's a whole lot that goes into that. We're going to be focusing more on the modeling side today. But again, we've got some time for questions at the end. So if you have questions about this collaborative side of things, we can go over that after we finish making that clamp. And then in Fusion, you've got on your left, you saw me use a second ago, all of your workspaces. So in Fusion, you've got a modeling space, which is essentially 3D parametric modeling as well as sculpting. Patch, which works sort of as like a surface modeler that you can then take and make things into 3D. So if you're used to more surface modeling, you can do it that way. Rendering is the rendering space that I just showed you, where you can get some photorealistic images. Animations are sort of like exploded views, animations, changing the camera angle, that sort of stuff to make a video. Simulation is full FEA analysis, so you've got things like static stress analysis, thermal conductivity analysis, all that good stuff. And you can go in and actually make sure that it's going to work in the real world that way. And then you've got CAM. And CAM is the space where you go in and define what tools you're going to use. It develops the tool path for you. But the great thing about Fusion, and kind of like our goal with it, was to be able to make a model in one space and then have all these different things like G-code that exports out to CAM, or renders, or animations. All of these things that update as you change your model. So if you made a CAM file for, say, the base of this lamp, if you change the base of the lamp, it would automatically change your CAM file as well. And that's kind of what we want to have, is one integrated experience so you can design all this stuff together. And so when you're designing this, you've got, let's see, you've got a question. Let's see, video's over. Look at this video. Oh, good question. So someone just asked if, Alan just asked if, when this is over, if you have access to a recording. I am recording it now, so you'll have access to it. I'll send it out. I believe you'll all get a link to it. It's going to be, I'm going to be going relatively fast. Hopefully not too fast. And if I am going too fast, say so in the questions. But there's a lot to cover in an hour, so hopefully you'll be able to, not hopefully, you will be able to go back and look at this video and catch up as well. So, but feel free to ask any other questions. Thanks, Alan. That's a good point that I forgot to cover. Yeah, so when you're in Fusion now, you've got, I'm just going to show you the basic stuff in the environment here. Up at the top, you have a toolbar. So each of these toolbars has drop-down menus. There's one that's called Create. And the Create one is going to show you any tool that brings something into 3 dimensions. So if you've got a sketch, or if you don't have anything, you can either do something with that sketch, like pull it out, or you can make something completely new, like a box or a cylinder. And if you hover over any of these, it'll give you a little explanation out to the side to show you what kind of tool you're working with. The next one is Modify, and that's going to change anything that already exists. So I wanted to, say, shell out a part of this lamp. I could use the shell tool and click on that body and shell something out. Or fillet, these are all things that you're probably used to if you've used other software. If you're not used to these tools, just hover over them and they'll give you a little description there, and you can kind of play around and find them. We'll be using a lot of them today on the clamp, so you'll be able to get a good idea of what those are. The Assemble menu is more for things that are moving around. So if you have an assembly and you've got parts that are interacting and aligning and moving and joining, that's all going to happen here under the Assemble menu. We're not going to cover any of that today. There's a separate webinar that goes over assemblies and motion studies, and so I would definitely recommend it. It's a really helpful one. If you have any questions about it, I can fill those at the end as well. The Sketch menu is going to show you all of your 2D sketch options. You're just drawing 2D sketches. The Construct menu will show you everything that's your reference geometry. So if you have planes in space, or axes in space, or points in space, if you're not familiar with construction geometry, they're just things that exist in the 3D space that let you build off of them and design from them and reference them. They're not actual physical things like a model would be. The Inspect menu can give you a lot of information about your model, like curve analysis, or you can measure between certain points. Inflict is going to give you things like decals that you can slap onto it. Make is going to be a menu where you can send this off to, say, a 3D printer, or get a quote from BrightHub, for instance. Then you also have add-ons, and then a selection box that just lets you pick your different tools to select them. And then also you've got, over here on the left, is a browser of everything that exists. So this is a poorly made model in the sense that I did not name any of these bodies, so they're just like listed there. But if you click on them, these correspond to a physical part in space. Same with the sketches, as well as construction. But to make these things, all of that happened through different actions that we're taking, and those actions show up on the timeline down here. So if I were to go back in time to, let's say, this point, we'll find where I first began modeling this. And at this point I had one body and one sketch, but that body and sketch were created using one sketch and 3 subsequent extrusion. And you'll see what that means when we did the clamp as well. But the point here is just to show you that any action you take shows up here on your timeline, and you can go back and forth in time to edit these things. But all of the results of your actions show up here on the browser. And the reason for that is that if you wanted to go back in time and change something, you want Fusion to be able to linearly go through and recalculate everything. That way everything updates really smoothly. And it gives you a really nice, hopefully error-free solution whenever you update it down the line. Let's see, we have another quick question. Let's see. Can't see yet. What is the main benefit of Fusion against Inventor? Andres, I hope I'm saying that right, has asked what's the best benefit for Fusion against Inventor. There's a lot to pack into that question. It's a different design workflow, so Fusion works from a top-down design as opposed to a bottoms-up design. So you're designing a whole assembly in one space, and you have a very collaborative environment. Inventor is a bit more classic. It's more of a bottoms-up, which you can also use to design in Fusion, but Fusion is really optimized for top-down workflow. There's a whole lot more to explain to that, but I guess the practical thing would be if you're designing like a complete tractor from scratch, I would use Inventor. There's a lot that goes into why I would say that, but if you're designing something like a consumer product or a machine or like furniture, things like that, Fusion works really great. Fusion, you can do a whole lot with it. It's just a matter of which one's better for your workflow, but they do work a little bit differently, both of them. Let's see. All right, let's check to make sure. There's another question here. Could you start in the middle? I'm not sure what that means, Brandon, if you want to clarify that. If you mean in the middle of the timeline, I can scroll through here and take a look at, at any point in time what this model looks like, going through each of the steps. I don't know if that's what you meant. If it's not, let me know and I can clarify that. But for now, I'll go ahead and just jump into the model. And when I do, let's see, can you show how to add construction lines that are not used in the model as part lines, i.e., they are only an aid? Yes, we will do that. I'm sorry, Stephen asked the question, can you make construction lines? Doing that with the clamp, you'll see it there. Good questions, thanks. And if I didn't answer them, let me know. I'm having to do this at the same time, so I just want to make sure I get them all. Brandon's asking, you start building something from the middle. I assume from the middle of the timeline you mean, and you absolutely can. I can go in here and say, go to create and make a box, and that box will show up right here in the middle of the timeline. You can start adding things at any point in the space, and you can also go back and change at any point. And you'll see that timeline work as we go through the clamp. You'll see it kind of go through as we go. So to do that, I'm going to go ahead and just jump right into the clamp. And so just to show you again what we've got here, this is the clamp we're making. And when I'm thinking about how to design this, I can kind of start with, what's the most basic shapes that I could start working through. So one of the main ones that I'm obviously seeing first is this big cylindrical pipe clamp that goes through the middle there. I've got sort of a protrusion that comes off of the top of it and a slit that goes through them. And then I've got sort of a T-shaped leg base, and then I've got a plank that goes on the bottom here. So what I'm going to do, in my mind, I think, okay, the first thing I want is just to get a cylinder out. I know that that cylinder is going to be about the same width as this top piece that goes across it. And so I'm going to make something to kind of extrude up from that. I know I want to round it off at the top and put a hole through it so we can put something else there, and a slit to go through as well. And then I'm going to just do this by doing sketches and extrusions. So I'm going to start us off with a primitive shape. So if you go to create, there's a tool here called cylinder. And the primitive shapes, we call them, are these first section that's up here. And they're primitive because you have relatively little control over really specific details of them. So you can make a cylinder by doing a sketch of a circle and then extruding it up. Or you can start with just a cylinder on the primitive shape. I would suggest that primitive shapes are really great for starting a model. They're a little bit more difficult for editing a model because they have less constraints that you can put on them. That's why they're primitive, but they're great starting points. So what I'm going to do is I'm going to click on that cylinder there under Create, and then I'm going to choose a plane to draw on. Fusion automatically starts me off with 3 main work planes, and I'm going to pick the left side to begin my clamp off of. Now on here, I've got a little, if you look, there's like a little crosshairs there where my circle is, and I can click on the origin once, and then if I drag away with my finger off of the button, it lets me go through and define a very particular dimension for the circle. I can either click somewhere or I can type in something specific. Now I know that I want my diameter for this circle to be 70 millimeters, so I'm just going to type in 70, and then I'll hit enter. And I want it to come out a certain distance, and I can either type that in directly, which you can see here on this box on the right side, or I can push and pull. A lot of tools in Fusion, not a lot, most tools in Fusion allow you to either do things manually in space or with very precise numbers on the right side over here. And all of these you can access again later. So for the height, I'm going to say 40 millimeters. And then I'm going to click on OK. And that's going to give me the start of my clamp. And just to show you at the same angle that our picture is, that's what we're doing right here. So the next thing I want to do is make a rectangle across the center plane of this circle and extrude it up to the height of the top of the clamp. So what I'm going to do there is hit my home button over here. And I forgot to mention also, the navigation tools in Fusion are pretty simple. You've got a view cube over here on the right, and you can click on any face or any edge or corner. You can also click and drag, or you can click on the home button and go to a saved view. So if you have a particular view that you use a lot, you can right-click your view cube and say save that view as home view. And then you can always click on it on the home button there. But by default, it's this corner between the top, front, and back plane. So from this, I'm going to create a sketch. So when you're working with sketches, you always want to create a sketch first and then choose a plane on which to draw that sketch. So I want to put it right here in the middle. And if you look, you can kind of see the top half of that circle become lighter than the bottom half. That's showing you where your plane is intersecting that body. So I know that we're right in the middle of the circle here. And if I click on it, it's going to start the sketch for me. Now I'm going to click on the top of the view cube so that I can see it a little bit better. And I'm going to scoot Fusion a little bit because my webinar buttons are covering it up for me. And then from here, what I want to do is create the rectangular piece that goes across the top. So I'm going to come into Sketch, and I'm going to say Project Include. And the reason I want to do this is because Project lets me go in and click on a body. So I'm going to make sure my selection filter here says body. If I click on it, it's going to give me purple lines that outline that shape. So what that means is that all these purple lines are a reference to an outside body. So if that outside body were to ever change, my sketch would change as well. And so if I do that, I can come in here with a center rectangle. I can hover over the origin over here and then move it to the right. That's going to give it, keep it horizontal to the origin. And I'll click once. And then I'll move it out kind of just roughly to make a rectangle and click again. And when I do that, I've got a rectangle that's defined by a center point as well as 4 edges. And so the first thing that I want to do is just make sure that this top edge is on the same level, or at the same, is coincident to the edge of my circle that's here, but the edge of my cylinder that I've made. And the same for the bottom. So in Fusion, you've got constraints over here on the right for your sketch palette. And in there, I can go in here and say collinear. It's one of the constraints that are listed. And if I just click on the top of my rectangle and then that purple line that we had projected, it will go in and make sure that that line is now attached to that other one. So it's always going to be there. You see I can't move it up and down, but I can move it longer or shorter. I'm going to do the same thing now, a collinear constraint between the bottom of the rectangle and the bottom of that cylinder that we have. And we're very close now. Actually, I'm going to backtrack. I'll hit Apple V to undo that because there's a different constraint that I want for that one. I don't want a collinear constraint. What I want is a constraint that will make sure that the center of this box is in the center of this cylinder. So if I go to midpoint, there's a constraint called midpoint. And if I click on that first line and the second line, it's going to take the middle of the first line and make it constrained to the middle of the second line. So now we've got a rectangle that will not move up or down, but it is constrained to that midpoint. If I change one length, it'll change the other one as well. And then the last thing that I want to do is just define a width for this rectangle. So if I go up here to Sketch Dimension, you can find this under Sketch and down here at the bottom for Sketch Dimension. And that's going to let me choose these 2 lines and give them a certain distance. So if I click on, double-click on that the dimension that I just made, I can make this 28 millimeters. And now I have a fully constrained box. So if you notice before, we had a box that had blue lines. Now they have black lines. And that black is Fusion telling you that it's fully constrained. And we also have dotted lines. And these dotted lines came through when we made our center point rectangle. and these are construction lines, which I know one of you was asking about just a minute ago. And if you click on any line, there's a little button over here on the sketch palette that says normal construction, and it switches back and forth. So I can turn that into a normal line, or I can switch it back to construction. And construction just means that they aren't lines that can create anything. They're just there as a reference to drive the geometries of your real line. So I can't go through and, like, extrude a pyramid out of this triangle, because Fusion doesn't see this triangle as being something that exists. It sees this rectangle as existing, and it sees these two construction lines as defining that rectangle. So once I have that, I'm going to hit Stop Sketch, and that's going to take me back out into the namespace. And if I click the little house button over here, you can see our new profile that's going across. And when you're sketching, it's important to make sure that your profiles have sort of a yellow color interior, and that means that you have a fully enclosed path. So if you're looking at it, making it into something three-dimensional, it has to be a fully enclosed path. So make sure that those lines fill an orange space. Now I'm going to use the Extrude tool to extrude one of the profiles that I made to make the top of this clamp. So I can pick any of the three that I created. I'm going to pick this middle one. And again, I can draw it straight up, or I can type in a specific number. But one thing to note about this is that since we're going through some material, Fusion automatically assumes that it's going to cut something for you. But this same extrude tool can cut, it can join, intersect, or make a new body. And in this case, we want to join it together because we want this to be part of the same thing. And then for the distance, I'm going to type in 56 millimeters and say OK. So now we've got our clamp circle with the top extrusion coming out. And if I look back at my clamp, it's got a rounded top and a circle that goes through it. So that's the next thing I want to take care of, is just make sure that that geometry is accurate. And again, when you're doing anything in CAD modeling, especially in Fusion, there's 1,000 ways you can go about doing something. For this one, I'm going to choose to do a sketch just so that you can get a better understanding of how the sketching works. But just keep in mind, there's a bunch of ways that you could do this. I did that kind of fast. I'm just going to hit Stop Sketch, and I'm going to delete that action real quick. What I did here was I clicked on Create Sketch, and I clicked on the side of the part. So in Fusion, you can click off of work planes, or you can click off of the sides of parts that already exist. So I click on there. You can see that it's already filled in orange for me, and that's because when you make a sketch on the side of a part, it automatically pulls in all of the edges of that part into your sketch. And so that creates right now a closed loop, so we all have something that we can work with. But what I want to do is give it an arc across the top and a circle to cut out of it. If I go to Sketch, there's a tool in here called Arc, and there's one called 3-point arc. With the 3-point arc, I can define 3 different points, and I can, whoops, sorry, do that again. I can define 3 different points, so I'm going to do the left side and the right side of the arc, and then I can pull it up to match the top. And then from that, I want to make sure that this arc is actually tangent to each of these edges that it touches. So I'm going to go over here to Constraints, this one called Tangent, and I can click on that arc and the side line. I can click on the arc and this side line, and I can click on the arc and that line. So now I know that I have a full semicircle that is tangent to all 3 of those faces. So next I want to do the circle that goes through it. So under Sketch, there's one called Circle, and under there I can choose Center Diameter Circle. And that lets me click on the center point that was made by this arc, and I can type in a very specific number, so I can do 12 millimeters if I want, and say OK. And that created a dimension that comes off of it. So I can move these dimensions around in space. Wherever it looks good, I can keep it there. And if I ever wanted to edit that, I could double-click it and change it to a different number. In this case, I want to keep it 12. So now I've got, if you kind of hover over, you can see the different profiles or closed loops that Fusion gives you. We've created 2 of these triangular pieces at the top that we want to cut out, as well as a circle to cut out too. So if I hit Stop, I move back into the environment, and I can come over here and turn my model around a little bit. And I want to cut these rectangles, or these profiles, through the entire part. So I'm going to go to Extrude under the Create menu. And once again, I'm going to choose the profiles that I want to work with. So I'm going to choose those 2, as well as the whole. And there's a lot of ways now that I can cut this out. I can either drag it all the way through, and that's going to chop it off for me. I can drag it a certain distance, so I can tell it exactly the amount that I want it to come out, which I think was 60 for the diameter of the circle. Do negative 60. Oh, negative 70, perhaps. Yeah, and that'll cut all the way to the edge. but none of that is particularly clean. One really clean way to do that is to choose extents down here and actually say 2. And that's going to define it going all the way through to a certain surface. So if I went back in time to edit this surface, it's going to update this extrusion that I have to make sure that it always stops that surface no matter where it is. So then I can say OK. So to give you an example of that, if I went back to my original, back here in my timeline, if I went back to the cylinder that I made originally, I can double click it. And if I do that, I can change my diameter to 80 millimeters and say OK. And now you'll see that even though this thing is longer, it's updated that extrusion that I went through and made sure that it stopped at the same surface. I'm going to hit Apple Z just to go back before I change it. But that way you can keep things really smooth and parametric, and that's a good way to make sure that your model is clean going down the line. Let me just check and make sure we don't have any questions. I'm going through it a little bit quick. Let's see. You mentioned Inventor. I'm familiar with Inventor 16. What is this going to do? Okay, so I will, the questions about Inventor, I will talk about after we finish up the clamp. It's a longer discussion, but it's definitely a good question. We'll get over that in a little bit. Let's see, you can edit sketches directly without opening them, same as in SolidWorks. Yes, so Andres has asked if you can edit the sketches without opening them directly. You can if they're showing. If they are fully constrained, you might have to enter a sketch in order to edit one of the constraints. But the geometry is always visible here on the browser, so I can go back and show using the light bulb any one of these sketches, and I can click on this line and drag it to edit that sketch. However, that's a fully defined sketch that I made, so I have to go into the sketch to actually edit it and change it. And that can happen either by right-clicking it on the in the timeline or by right-clicking it in the browser. Both of them have an option to edit the sketch, and you can do it that way. And then Jason said, how do you right-click with using a Mac? And hotkeys, question mark. So on a Mac, I right-click I'm using my trackpad right now, and if I use 2 fingers and click, that will bring up the right-click option. And hotkeys, if you look at any one of these tools in the menu, they have little like E or H next to them. These are buttons that you can click that automatically go to that tool, so there are current built-in hotkeys, but you can't customize those yet. But what you can do is build your own toolbox. So if you're in Fusion, anywhere, you can hit the S key on your keyboard, and that'll bring up your toolbox, which lets you type in, like, if I wanted to use the combine tool, but I didn't want to go searching for it, I can type in S and then type in the word combine, and it'll bring it up for me so that I can see it. I can also pin that tool into my toolbox. So if it's one that I use a lot, I can just click S and then move straight to the combine tool and click on it and go from there. That's what we have for hotkeys right now. The ones that are built in are not editable just yet. And then Mariana asks, is it possible to recognize the operations of an object imported from Inventor? Does it open an IPT file? Yes. So Fusion will open pretty much any 3D file type. It's pretty good about it. In fact, we actually have people who only use Fusion to open and convert files. It's kind of bizarre, but that's it's known for being very good at it. Depending on what file type you bring in, it can bring in a certain level of intelligence. So it will always bring in your file exactly like it is and be very accurate, but it may not recognize that something is a fillet that can be edited, or it may not recognize that something is, you know, like a draft or something. So what you can do then is go into Fusion's direct modeling, but that's a whole other discussion. I would definitely recommend looking it up on YouTube if you want. There's some great tutorial videos on direct modeling imported geometries. But Fusion will take an Inventor file with a great deal of intelligence. So Inventor is really the best one to bring in. Fusion can, you know, understand a lot of it. So it should be a pretty smooth process for you, Mariana. Good questions, guys. Thank you. So the next thing I want to do is create this this sort of T-shaped, what is it, a foot maybe? I don't know, whatever. This base that comes down off of it is a T-shape. So we're going to do that, and then we're going to create the base to go on it, and then we're going to actually cut out the center for the pipe. So what I'm going to do here for the base is create another sketch. So if I go up here to sketch, there's one called create sketch. And I'm going to pick this bottom plane to draw, and that bottom plane is still going through the middle of this circle. And that's because if you look at it here, we define that cylinder being on the origin. So it's always going to have those 3 planes going through it directly. Now if I want to click on that bottom plane, you'll notice that there's a lot of things that I can click on that are in front of it, like the circle that it's highlighting now. If you ever have something and you want to click on something behind it, you can click and hold. Sorry, I just clicked once. I didn't click and hold. Didn't even listen to myself. If I click and hold, it'll bring up a little sub-menu that lets you choose what's behind your mouse. So right now, I can click on either the face of the circle, or the back face of the circle, or the work plane that's in between. If I click on that, it's going to give me a sketch that's on that plane. And what I want to do now is look at it from the top so that I see it from the top view. I want to draw out two rectangles that will make the base going across the top as well as the middle for the T. So doing that, I'm going to come up here and do the same thing we did before. I'm going to go to rectangle and say a 2-point rectangle. And I'm just going to draw it very rough. I like designing with constraints, so I don't worry too much about where things are in the beginning. I try to get them constrained as quickly as I can, and then I can measure them out after that. So what I want to do here is make sure that this, the back of the T-clamp is level with the side of that extrusion that we brought up. So I want this line to be the same as this line. And even though we didn't project it, remember before we projected a line from the outside into the sketch? Even without projecting it, I can still come in here and say to do a midpoint between this line and this line. So you don't always have to project things, but the project is very handy if you're going to build a lot off of a line, because it gives you a little bit more control. Like this automatically projected it for me, so you can see it there turning purple. And that's kind of how you can build that in without having to click on it individually. I'm going to do the same thing again, the midpoint constraint between this line and that same projected line that we just made. So now I feel like we've got two rectangles that can change their width and their height, but they can't move away from this line that we constrained them to. And you see that too with like this rectangle here has a black line, so we know that it's fully constrained, but it has blue lines on the other side, meaning that they can all be different lengths, widths, and angles. So once we have that, I'm just going to go in and make sure that the bottom of the clamp is level with the outside of that cylinder. So I'm going to come in here to collinear, and I'm going to choose that bottom line, and I'm going to choose the bottom edge of the clamp. And then what I want to do is make sure that our widths for these two are the widths of that we want for the legs that come down. This is 6 millimeters, each 6 millimeters thick. So I want to come back to sketch, and again I want to choose the sketch dimension tool, and I can choose these two lines on either side of this rectangle, and I can make them 6 millimeters. And I can do the same for this tool. And while we're doing this, I should note too, Fusion takes any unit that you throw at it, so I can actually say like, 10 millimeters plus 1 inch. And Fusion will calculate that for me. So no matter what your standard units are in your model, you can type in whatever you want, and it saves it that way. So you can go back and edit it directly. But instead of 10 millimeters plus 1 inch, I want this one to also be 6 millimeters. Or if I want to make sure that it's always the same as this thickness, I can click on this guy's dimension, and it'll bring it automatically into here as D8. So those will always be the same now. If I change this to 10 millimeters, it'll do the same for our bottom T as well. We'll bring that back to 6. And then finally what I want to do is just give the T a width, so it's going to come in just a little bit from the side, and I need it to be about 60 millimeters wide. So I can either click on these 2 points or these 2 lines, but either way I'm going to draw a dimension, and I'm going to make it 60 millimeters. And so there we have a T, and right now it exists in the middle of our circle, and we're going to extrude that T down to make the feet. Before I do that, I'm just checking to make sure there are no questions just yet. I don't have any new ones. Again, if you have any, feel free to shoot them over. So what I'm going to do now is do the same extrude command that we did before. If I spin this over so we can see that T better, I'm going to go to Create and choose Extrude. And then I'm going to click on those 3 profiles that we have in our T. And again, I'm having trouble clicking through it, so you can click and hold, and you can choose the profile. I can click and hold and choose profile, and I can do the same thing for these 2. Now again, if I bring this down, if you'll remember, it's going to try to cut it at first because it thinks that we're going through some material. But I want to change the operation to join, make sure that it becomes a part of it. And again, I can drag this down to a certain width or length, or I can define the distance specifically. And I want this distance to be, let's see what I want it to be, -100 millimeters. I'm going to bring this down 100 and say OK. Now we're almost there. What we need to do now is just build out our base, add some curvature to some corners, and then cut out our center circle here. So for the base, if we look at it over here, we have a base that touches the back of the T, it touches the front of the T, and it has 2 holes that cut through it. Now in Fusion, I could design this as a box. I could put a primitive box down there and then use the hole tool to cut some holes through it. I could also make half of it and mirror it over itself. There's also ways to approach it. What I'm going to do is just draw a rectangle, same as them before, and I'm going to add some circles to that rectangle. That way it'll automatically extrude this bar with the circles coming out of it. So I'm going to go into Sketch, and I'm going to choose Create Sketch. And then I'm going to choose where I want to draw it from. And in this case, I want to draw it from the plane that's on the bottom of my T. So I'm going to click on that T. And again, you'll notice that it turns orange, which means that it's already outlined the outside pattern for me. And I'm just going to go in now and draw a rectangle to create that base. So if I go to Sketch, I can say Rectangle and 2-point rectangle. And I'll do the same thing again. I'm just going to throw it out with reckless abandon, put in a rectangle, and then I'll use my constraints to go ahead and make sure that it's always connected. And the reason the constraints are so handy as opposed to just typing in dimensions directly is that if I update any of these parts in this model, it's going to update these sketches and then update their extrusions as well. So these constraints are extremely handy for that. So now I've got a rectangle that is, let's see, whoops. You know what? I made the same mistake I did last time. I'm going to hit Control Z again, and I'm going to use a midpoint constraint rather than a collinear constraint, because again, I want to make sure that this rectangle is always centered over the T. And now I've got a rectangle that can be any length, but it's only one width. And so what I want to do now is just define the width of that rectangle, which I believe I want to be 120 millimeters. So I'm going to go to Sketch Dimension, and I'm going to click on both of those edges, and once again, make it 120 millimeters. And then now, if you look, my rectangle is black, so it is as constrained as it can be. And what I want to do is go ahead and put in the circle, the 2 circles to make the holes to cut through it. So in the same sketch, I can go up here to Circle, and I'm just going to draw one. Same as the rectangle, I'm just going to pick a point and draw it. And once I've done that, I can start positioning this circle where it needs to be. So the first thing I want to do is make sure that this circle is always right directly in between these 2 lines. So to do that, there's a lot of ways. I could draw a line going through the circle and make sure that it's at the center point of the lines. But an easy way, I think, to do it is just to go into Sketch and choose Point. And on that point, my mouse automatically snaps to the center point of this line if I hover over it. You'll see a little triangular blue icon. That's a constraint. I forgot to mention that. All of these little icons are representations of our constraints. So this shows that I have a collinear constraint between these 2 lines. This is showing a midpoint constraint that we gave it earlier. These are horizontal and vertical constraints. And those happen automatically as you're drawing your rectangle. Now what I want to do is make sure that the center point of this circle is always horizontal to the new point that I've made there on the midpoint of the line. So if I click on both of those centers, I can click on the horizontal vertical constraint, and it'll move it to make sure that now I can't move up and down. That circle can only move left and right from where it is. The next thing I want to do is make sure that that circle has a certain diameter, so I can click on the outside edge using my same Sketch Dimension tool. And from there, I can give it a certain diameter, which I'm going to make it 12. And the last thing I want to do is just make sure that, because if I move the circle, you'll see that it can still move left and right. I just want to define the distance between the center of the circle and the outside edge. So I clicked on the center of the circle and the outside edge. If I click the next one, I can say 12 millimeters. And now it's a fully constrained circle. Now, instead of doing this whole process again for the other side, I want to just mirror it all the way across the assembly. So to do that, I'm going to go to Sketch, and I'm going to say Line. That's also, if you press L on the keyboard, that'll bring it up as well. And I'm going to click on this midpoint at the top once, and I'm going to drag my line down and click on the origin. And that gives me a vertical line that I can then make construction. So on the sketch palette over here, there's one called normal construction, and if I click on it, you'll see that my line is now dotted, which just means that it's not a real line. It doesn't create anything. It only references things. And then I'm going to go to Sketch, and under Sketch, there's a tool called Mirror. And when I'm looking at Mirror, I can choose my objects, and then I can choose my mirror line. So I'm going to start with the objects, which is just going to be this circle. And then I'm going to choose my mirror line, which will be this dotted line that we made. And then I will say, OK. And now if I were to go back and change, say, the diameter of that circle, it's going to change the one that's on the other side as well because they have a mirrored relationship. And you see that mirrored relationship right here on this line as well as on each circle. So if you hover over any one of those mirror icons, it's going to light up the corresponding geometries that are part of that mirror function. I'm just going to check a look, make sure there aren't any questions yet. We've got one from Mariana. It says, can 2 or more persons work in the same project as a collaborative project, or at least to be able to edit the same project in the cloud? So everybody who is on the project can edit the model, absolutely. But it's not like Google Docs in the sense that you can't, like if I were to make this change, somebody else can't have the model open and watch that change be made. We have 2 things that there's a lot of ways that we share and collaborate. But typically, if you open the model to edit it and somebody else has it open, it will save a different version than yours. It'll be the same file, but it'll just have a separate version that says this is the version that Tanner was working on. And right now it's a linear process, but soon we'll have branching. So it lets you go through the process of merging different files together based on their versions. But we also have things called live design reviews, which is where you can share your screen and other people can watch you make changes. They can also take control and make changes themselves, or they can comment them in 3D. Again, the collaborative stuff, there's a whole lot that goes into that, so I'm not fully covering it by saying this right now, but hopefully if you want to Google it later, you can go look it up. Fusion has some really great videos on collaborative stuff. There's about 1,000 ways to do it, and it's all pretty handy. I also have somebody who said something is going on with your audio. Thanks, Steve, for letting me know. I'm just adjusting it to go right in front of my face again. I may have gotten a little bit off. Let me know if you still have problems hearing me, though. Yeah, so now we have our base drawn out. I'm going to say stop the sketch. And if I move around here, you'll see that our sketch is now on the bottom. And I can go to Create and say Extrude. And we're using Extrude a lot, but it's a really great tool. It's very handy. And I'm going to choose the profiles that I want to extrude. So if I wanted to extrude this stuff, I would click on these 2 profiles and the T. If I wanted to extrude them up, I would only have to click on the 2 profiles, but I could also click on the T. So if I move these down, for instance, you'll see it'll leave out that T. If I move them up, it's going to join them to my main body above the T. In that case, we don't actually need the T that's there. So what I'm going to do is move them up 8 millimeters. So we're going to go -8 and say that's going to automatically join them for me, and I can say OK. And Steve says the audio is better, so that's good. Thanks, Steve. I appreciate that. Excellent. So now that we have our base done, the next thing I want to do is add some fillets to this. So if you look at our model here, we've got some large fillets, and we've got some rounded fillets on the corners as well. And so what I'm going to do is go to Modify. And again, if you're trying to think when you're making this, like, where would I find fillets? A fillet is distinctively a change to an already existing part, so I would go to the Modify menu and find fillet. Also, if you're trying to find it again, you just type in the letter F. That's going to bring up your toolbox, and I can type in fillets, and it'll bring me up the different kind of fillet options that I have. If I click on the fillet tool, I'm going to click on these 2 lines right there. And again, I can either drag these out by hand, or I can give them a specific number. And I think the number we want is 12 millimeters. I'm going to give this guy 12. And then I'll say OK. And I want a separate fillet for these edges on the corners because I believe it needs to be a 3 millimeter radius instead. So I can go to Modify again and say Fillet. And I can click on all 4 of these and say 3 millimeters. And that will give us our rounded corners on the edge. And now the last thing that we want to do to make sure that this works is cut the hole out of the center. as well as the split that goes up the top. And again, multiple ways to do this. I'm going to do it with a sketch. So I'm going to start with the create a sketch button again. And I'm going to click on this side that we've created, and you'll see once again that it's drawn out the profile of the face that we've clicked on. And if I look at my right view here, I can come in and create a sketch and choose circle and say center diameter circle. If I click on the origin, I can move this out and make a circle that will then cut through. And I can either give this circle its own diameter, or if I wanted to be a little bit cleaner, I can click on that circle as well as a circle outside of it and give a distance between those two circles instead, which I think should be 5 millimeters, which it is there. And then what I want to do is add in the box for the slit that's going to go up the top. So I'm going to go into Sketch, and once again I'm going to choose Rectangle, 2-point rectangle, and I'm going to draw out roughly where that rectangle needs to be. Now again, I can come in here with the midpoint tool, which should be here, and I can choose that line for the bottom of the rectangle, and I can choose the origin, and it's going to center it there for me. I can also choose the collinear constraint once again and put it between this line and the top of the clamp. What you'll notice here is that the top of my clamp I can't click on because it doesn't have an edge that's there. That's the curvature that I'm looking at. So now is a good example of the time that we need to use project. So if I go to Sketch, I can say project, and I can make sure that I'm saying body here, and I can click on the body of the full clamp and say OK. And now I can use the collinear tool between that top edge of the rectangle and the top projected edge of our clamp. And now finally what I want to do is just give this, slot a dimension, which will be 3 millimeters. So if I go up to Sketch Dimension, I can click between the two lines and make it 3 millimeters. And then I can say Stop the Sketch. Now, if I'm going to extrude this, I have a few different profiles here. I want to extrude this center circle as well as this profile and this one. You might decide that you wanted to go ahead and clean this up a little bit before getting to that point. So if I wanted to go back and edit this sketch, I could double click on the sketch that's here. And if I know that I want to cut out a certain amount, I can use the trim tool. So if I go to Sketch, there's one in here called Trim. And I can trim out the parts that I know can be connected. So I know that these parts, this should be one solid profile. The problem with that is that when I delete those edges, I also lose the geometry that is defining it, that I've constrained specifically. So you've lost some intelligence with that, which means that you have to build some back in if you want to. I only show this just as an example. A lot of people like to have really clean sketches. They can then go back and edit and reconstrain. I'm totally fine with having extraneous stuff as long as that's actually driving it and constraining it with some intelligence. So I just hit Control-Z to backtrack through that, but just so that you know, you can make them really clean visually, but if you do, you have to just go back and clean up your constraints as well. I'm going to hit Stop Sketch, and I'm going to use the Extrude tool, and I'm going to extrude the center of the circle as well as the slit that's going to go all the way up. And I want to again choose 2 for the extent. That's going to send it to a certain surface. And I'm going to choose the other side of the clamp. I can also choose something like all, which is just going to do it through everything in space that's in that direction. I can also change it to be a 2-sided one, so it's going to go in both directions. But in this case, I just want a one-sided cut to the outside surface of the clamp. And then I can say OK. Once I've done that, the clamp is finished. If you look at our render over here that I was showing you earlier, it's got a lot of really beautiful edges that go along it, so you can see like the light is catching it really nicely on the sides. And that's because obviously in real life you're going to have a bit of an edge on any of these things. They're not going to be perfect corners. And so I'm going to add a fillet to all of it so that our render looks good. But first I'm just going to hit Apple S to save it. It's going to save it to whatever project I ask it to. So I can pick my project, and I can name it, let's say Clamp. And I'm going to move it to, I have one called Playing Around. We'll do that one. This will be Clamp Demo, and say Save. And now I'm going to go to Modify, and I'm going to do a fillet once again. And for this one, I'm going to click and drag to select all of my edges. And I'm going to do them at let's try 0.5 millimeters. 0.5, that looks good. And say OK. And now it's got fillets along all of the edges. If I wanted to keep designing things and I wanted to get rid of those fillets but not delete them, in the timeline, I can right-click on this fillet action that I took, and I can say suppress. So that way we're not deleting an action that we've taken, but we are hiding it, essentially. We're deactivating it for the moment. I can also right-click it and unsuppress it, and that's going to bring it back. So that when we go into the rendering space, hopefully this won't take forever, but if I click on this, there, it'll start rendering, and you can actually see what the clamp is going to look like once you finally finish it. Rendering is a really great part of the process if you're designing things, because at any point you can get a good idea and a good sense of what it's going to look like, how light's going to bounce off of it. You can put in like materials that emit light. So if you're making a lamp, you can make sure that the bulb turns on. It's a really great space to actually see how things are going to look and interact once the product is actually made. Awesome. Let me see if there's another question. Let's see. It says, can you add draft or taper to these surfaces? You absolutely can. You can do that at two different ways. Let's ask that question. Sorry, this is Jason. So Jason, you can do it two different ways. One of them would be to add a draft as you're designing it. So if I went back to, let's say, this, find a good one, this extrusion here, which is the base. If I double click on that extrusion, it's going to take me back in time to the point where I put it on the base. And on here, I can define a taper angle. So I can make that like a 2-degree taper angle. And you'll see there that it's tapered it out. I believe I can also do -2, and it'll go in the opposite direction. And just to exaggerate that for you, you can see it here. So you can design in your drafting with your extrusions that you're making. A lot of tools, not just extrusions, do give you the option for drafting and tolerances as you're going. The other way that you could do it, if you want to do it after the fact, is come up to Modify, and there's one in here called Draft. And for that, you pick a particular surface, like this one, and then I can pick a surface that I want to draft from it, which would be, oops, there we go. You want to pick the plane to be, let's see, how about this one? Try it again. Do that plane, and then we'll pick our face to be this face here, which is, there we go, no changing chain. And I can draft it, well, let's see, that's gonna, that's doing it. Sorry, I haven't tried to draft this clamp to actually know where a smart place to draft this would be, so I haven't really played with it. But this is how you draft after the fact. It's a draft tool. You pick your plane that defines your angle that you're drafting from, and then it'll draft the face that you click on after that. So you can either draft in the moment, or you can draft after the fact. If you draft after the fact, it'll give you an action on the timeline that shows that drafting. If you draft in the moment, it saves that draft, but it saves it within the extrusion that you made before. So finding it is a little bit different, but it just depends on what you're doing and what your preferred workflow is. Good question, Jason. There's another one from Webb that says, will we get a link to the recording of this session by email? Yes, you will. I believe we'll be sending those out. So you'll definitely get that. Good question. Then we've got Mariana asking, can I use an image, maybe a construction plane, to draw a sketch so I can select the lines in the image and convert it? So Mariana, there's a few different things that we can do to draw off of images. Fusion will not convert the edges of an image to a vector file. So sort of like, if you're an illustrator, you can do an image trace. Fusion doesn't do an image trace, but Fusion, if you go into Insert, there's one here called Attached Canvas. And if you look at this attached canvas, I could show you pulling in an image using this, but it's pretty straightforward if you play with it. I'll just show you the image that it gives us as an example. An attached canvas is a floating image in space that you can then design around. So in this case, someone has put a car as an attached canvas, and then they're using the sculpted bodies to sculpt to that image. You could also put an attached image and then trace around it. The attached images are also handy in that you can calibrate them. So if I brought in that car, for instance, I could pick 2 points on that image that I know the distance between, type it in, and then Fusion will stretch that car out to be the size that you calibrate it to be. And you can design around it that way. But it won't I can't ask Fusion to turn this image of the car into sketch profiles. I have to actually generate those sketches myself. Excuse me, but you can bring in SVG files or DXF files into Fusion, and those will automatically convert into sketches, and then you can edit them. Good question, Mariana. That's a good one. Let's see. All right, we've got 2 minutes left, and there are no other questions in the bank. If I missed your question, would you mind asking it again, because I get a little bit lost trying to go back and forth between the CAD model and the questions. If there's another one, let me know. We'll let that go for just a second. While I'm waiting for any straggling questions, real quick, if you want to learn more, so if you want to keep going with this, we have other webinars that we'll be posting. You'll hear word about that. Or if you go to the Learn section of the Fusion website, there's a lot of great tools in there to get you started. Some really quick tutorials that you can go through. You can also Google things like, how do I extrude something, or how do I draft something in Fusion 360? And a YouTube video will pop up, probably multiple ones that you can look at, and hopefully find some answers there. And then finally, I send people to the forums all the time, and they kind of gripe at me a little bit, like, oh, I send me to the forum. But I know for a fact, because I am one of the ones who does this, that the forum questions get answered quicker than any other means of getting help. So if you can't find a YouTube video, usually it's the same day, hopefully within a few hours. But if not, it'll be like by the next day. You'll get an answer from the forum, and it could be something as simple as like, I can't figure this out, versus like, I have this crazy model and I'm trying to figure out how to do something special, and how can you help me? Either an expert or a Fusion employee will help you kind of work through that workflow and get you started with it. So again, under community and forums, it's a great place to get your questions answered. But again, most of them you can probably find answers to either in the Learn section or in through YouTube searching. We've got another one from Mike. It says, oh, excellent presentation, thanks. Well, thanks, Mike, I appreciate that. And with that, it's 5 p.m. I don't have any other questions I don't see, so hopefully I got everything answered for you. I hope this was helpful. I hope it gives you a good idea of where to get started. I know I went through kind of quickly, but again, there'll be the recordings so that you can take a look at it later. And with that, I will let you go. Thanks again for joining, and have a good one.